Welcome friends. Now in this set of video lectures we will be talking about statistics. Now you may wonder why we biologists are interested about statistics. Now for that reason I am going to do this video, which is the introductory part about the biostatistics. Especially when we talk about biostatistics, remember this term biostatistics or biostat. We are talking more about statistic and less about biological application. So simply it's the use of statistics to manipulate and understand the data that we can obtain from biological experiments. Okay, now what statistics is doing? Statistics is the subject, or statistics is some subject which help us to understand the meaning of data. That means there are a lot of data that are coming around us all the time. When we do experiments, set of experiments, get results, get a lot of different types of data. Now to manipulate, to arrange all those data and then present it in such a way that it can make some sense is very important, and that thing is done utilizing statistics. Okay, so we need to imply the statistics in various purposes, like in understanding any kind of science field like chemistry, biology and all these things. So you must learn at least the basic of statistics so that you can handle your data, your experimental data well. Okay, so again I'm telling you, I'm not a major in statistics. I'm simply a biologist, but I want to understand what is statistics, and I also want you to understand what statistics, because if you want to be a good biologist, you must understand how to arrange your data when you gather from the experimental procedures or from the results. Now in this set of videos, frequent videos, we'll be talking about several small different aspects of statistics, and then we'll be seeing how to arrange those data and can implicate those data in the biological system and to understand the result that is coming out from our experiments. Okay, so I'm not going to talk about detail of statistics. I'm not going to talk about the implication of statistics in business and other fields, simply in the field of biology. Okay, so here uh, in this first video we'll be talking about the introduction and obviously about the most important part of statistics, and that is data. Now, data is something that we can obtain from various sources. Now in this case, as I have told you, we can obtain the data from our experimental results. Okay, and we need to arrange the data and also uh, place the data in such a way, represent the data in such a way so that we can understand this. Now if you know that various aspects in your books also you have seen, there are simple representation by means of graph, like that, representation by means of these different types of curves, like this, representation of this kind of chart which we call a pie chart and so on. Also we have seen different type of representation of data, and all of these things are simply representation of data. Now why we represent this data? Because it is if we once we represent the data in these pictorial forms, it will become easier for us to understand what is going on those data and what are the important facts that are told by the data to us. Okay, so that is why we want to make a pictorial representation, a graphical representation of those data. Now simply when you talk about data, I'm not going to talk much. I'll talk some simple aspects of the data. When we talk about data which we can gather from various sources, I'm not going to talk about those sources even. Now from the type of source of data we get, it can be of two different type. It can be a vast majority of data which we get from a whole population. So let me write it here. So we can get it from a whole population, or we can get it from a fraction of a population. So we can get the data from both the sources, from the whole population and also from a fraction of a population. Okay, suppose this population is consisting of 100 different items. Now this population is only 20 of it, so it's a fraction of that whole population, but we can gather data from it. Now if it is possible for gathering data from a whole population, you must go with it, because then you get a clear picture of all the data. For example, you want to notice, in case of, if you take the example of biological field, you want to notice, for example, say in evolutionary biology, if you want to notice that after shifting a particular lizard into a different climate, you want to know how long or how what is the length change, a change in length in their tail. So you need to measure it. If you have the measurement of the whole population, or each member of the population, which is 100 here, you get a sufficient data to optimize. But now if you get if you don't know, if you are unable to get the data from all the population, suppose you are only able to get the data from only 20 individual of the whole population, which is big, 100 individual. Now what we will do, due to this, you will take this small amount of data in those cases. Now you need to do the results and you need to do all these things with this small amount of data, because you are unable to get this data of whole population. Both the things can happen. Now if this thing happens, if you get the data of whole population, you will get the population data, so you will process them differently than the data you get from the fraction. You process this differently. Okay, and all the data sets that we coming from the population is, and the number of individuals in the population is mentioned as capital N, but on the other hand the number of individuals present in a fraction of population is denoted by small n. And not only n, but also different parameters that you are going to see in case of the whole population and fraction population are varying in this. So whole population always denoted with the capital letter words, alphabets, and the fraction of the population is always denoted with the small letter alphabets. On the other hand, this fraction of population letters are also called sample population. This is called the whole population, and this is one the sample. Okay, so whatever we're talking about, the averages and everything that we'll be calculating will be different from population and sample. Okay, so this is the concept of population and sample. So let me write it here. This is also called sample. Okay, so this is about the data that you can get depending upon the sources. After that, we need to understand another important concept, that the type of data. The type of data can be divided into various aspects, into various types, but here we are interested in a simple type, that the data can again be divided into two different parts. One is called a frequency data, another one is called non-frequency data. So let me write it. Frequency data and non-frequency data. Now what do we mean by that? Now in non-frequency data, it's simply random numbers that we can get. Suppose for example you want to look for the length of you want to look for the length of the tail inside a population. Simple as that. Okay, now you get the results. For example, the length of the tail is, say someone it's in, suppose in centimeter, you get 5 centimeter, 11 centimeter, 6 centimeter, 8 centimeter, 9 centimeter, and so on. So this is the random type of data that you get from your population. So this is called a non-frequency, because all we get is a number, one type of number, no different numbers. Now in case of frequency data, you are more specific. In frequency data, you are more specific about your parameters. For example, in this case, you also want to notice that the length of their tail. So you get the length of the tail in centimeters, but you also want the frequency. Frequency means how many times that length is in the population. That means you now tell that yes, first of all, the length of tail is 5 centimeter, but now the 5 centimeter tail length is repeated in the population 2 times. That means among the 100 individual of the population, 2 of them is having the 5 centimeter tail. Similarly, 11 centimeter tail is repeated say 5 times. So the frequency of this 11 data, or this data set, is called 5. Right? Now say the 6 centimeter is 12. So the frequency of this 6 centimeter tail length is 12. That means in this whole population, 12 individual is having the tail 6 centimeter. Okay, so now the data is really sufficient. The data is more specific. In this case, you don't understand. You never know the number of individuals that are getting it or the frequency, but here frequency is given. Though the data is more specific and enriched, to deal with this kind of data, it will be much more tedious. because all the way we will be dealing with each of the datas with simple formulas. Now if you get simple datas like this non-frequency type, the formula will be easy, it will be easy to calculate. But again in the frequency data, formula will be difficult, it will be difficult to calculate. Okay, simple as that. And once we get a set of numbers like that, set of datas, it will be called as a data set. It will be called as a data set. So it's a set of datas. And another important terminology is that once we get a table like that, so say the table is described like that, say they are telling you the length of tail in centimeter in one column, in the other column they are giving you frequencies, and they are telling you that for 5 it is 2, for 11 it is 5, for 6 it is 12. So they are giving a bunch of set of data. For example, for 8 it is 6. So they are giving a bunch of data like that in a tabular form. Now we call this type of table a frequency distribution table. This is a frequency type table, and this type of data is called frequency data. Now this is a simple, little bit more complicated than this type of non-frequency data. So these are the two types of data. Okay, this is simplest, this is slight complicated. Now there is another type of data that can also be possible, which is much more complicated than this data, which is much more complicated. Now why we trying to make this data? Now once we start to make the complicated, for example, here is only 100 individual in the population. Now let's say there is instead of that amount of individual, what we get, suppose we get 1000 individual in the population. So now the calculation of this particular parameter, which is the length of the tail, will become much more tedious for us because the number of individual get increased. So what we can do, instead of individually writing frequencies of each of these lengths, what we can do, we can give a range of the population. We can give a range. For example, now we never call this particular thing. What we are doing, now we want to know the length of the tail depending upon the age of the lizard. Try to understand the point. Previously we are only interested in the length of the length, okay, and the frequency of the length, simply with these two types of data. Now what we want to know, the length or the increment of the length depending upon the age, right? Because it's true, when the lizard is small, the length tail length will be less. When the lizard is large, long, the tail will be long. Now that's why we interest to understand the age limit for their tail length. So the relation of their age with tail length. Now for that we need to make another table. Now in that kind of cases, what is the table going to be? It is going to be much more complicated. Suppose there are 100, suppose not 1000, say take only 100 individuals are there, but it will be difficult for us to understand the exact age of the lizard, right? How can we understand the exact age of the lizard? It will be difficult. But what we can do, we can set a range of ages, that this lizard may be from 1 year, for say 1 month to 2 months, this is for 2 to 3, this is for 3 to 4, and so on. We get the age length of their tail in those cases. So what we get in that case, we get again the length, length of tail again in centimeter with, it's not, so what we get here, age. Okay, so age, and here we get the length in centimeter. So what we get here, suppose we say the 1 month to 2 month range of age, so it is in months. So age limit is 1 to 2 months, and the length simply 3 centimeter. Now say 2 to 3 months, it is approximately 5. 3 to 4 months, it is 6. 4 to 5 months, it is 8. Now say 5 to 6 months, it is 9. So suppose this is a range of information that is given. Now this is another type of data, right, where we get a range in a particular section of the column. On the other section we get our data values or variables, right? So in this case, in this data, what is the difference between these two types of data? Both are having two columns, one for a particular parameter, another for its frequency in this case. So the data values that are getting is only 1 and 1, but in this case the data value for this first column is a range, right? It is giving us a range, and this range is creating our calculation much more difficult, because here we get a perfect value, right? The exact value, so it will be easier for us to calculate the parameters what we want to calculate. But here we get a range of values instead of one value, right? So we need to derive that single value from this set of values. So this is also called, this particular limits are also called class. They are called classes. So here this is a class, this is another class, this is another class. So why we are dividing them into classes? Because each of their class are having a particular property, a particular characteristic. For example, the class of 3 to 4 month of age is having the characteristic of 6 centimeter long tail, which this characteristic is never repeated in rest of the place. You can see. So this is the importance. But whenever we are, this is another important assumption, whenever we are taking a lot of informations and try to make them compact, what we get is a loss of information. When we get a lot of information, we write it down in huge formats, we get all the informations, but when you try to write them compactly, we lost informations. Now here also we lost information, because we, instead of getting a perfect value, we get a range of values, because it is difficult for us to measure the exact age of the lizard. Okay, so that is another important aspect. Now this type of data is also called group data. Okay, so this is also frequency data, but this is a group type of data. Okay, now this group data is the most difficult to deal with, because they are having the variables, they are having the classes, right? So among this group data, now I'll be looking at some of the important terminologies of the group data. So what are the terminologies here? So here in each group data, as we can see in this case, so let us take this one. This is the group data. Now in this left hand column, what we have, the class, right? So in the class will be one class is a 3 to 4. This is one class. So class 1, this will be the class 1, this is class 2, this is class 3, this is class 4, this is class 5, and so on. So the third class, so it is a range of 3 to 4, and among them, this is the lower limit, so we call it the lower class boundary, and this is the highest limit or upper limit, so we call it upper class boundary. These are the terminologies you want to know. That's why I'm telling you this, because in future slides, when we are in future videos, when we will be taking the examples and solving the problems, we require these terminologies. So please be clear about these terminologies. This is called the lower class boundary, this is called the upper class boundary. Now each of the class is having its lower class boundary and also its upper class boundary. For example, this one is having, this 1 is the lower class, this 2 is upper class, this 2 is here, in the second is lower class, 3 is upper class, and so on. It is going like that. Now here, this is, and the distance and the range of the class is called the class width. So the range is called class width. So how many datas or how many simple elements are there in this class? So 3 and 4, only 2 elements are there. So the width of the class is 2. So this is also called class width. This is also called the class width. Another important thing is there, which is called class limit. Now what is class limit? Class limit is something which is the highest for this highest capacity for that class. Now in each case, the formula of class limit is simply taking the upper class boundary minus the lower class boundary plus 1. This is the formula for getting the class limit. Upper class boundary minus the lower class boundary plus 1. So here the upper class boundary is 4 minus the lower class boundary is 3 plus 1. So here the class limit will be 2 plus 1 equals to 1 plus 1 equals to 2. Okay, so this is class limit. So you can see here, you can say this class width and class limit is similar, but it's not always same, because we need to add 1 with the upper class boundary minus lower class boundary value to get our class limit. This class limit is also very important. Another important parameter and nomenclature I want to tell you is about called the midpoint. Now as the term suggests, it is called midpoint. So midpoint means when you get this kind of group datas, like here's the classes 3 to 4, 4 to 5, the middle of each of these variable data is called the midpoint. So here in this case, this class 3 to 4, so what is the middle of this 3 to 4? The range is 3.5 simply. So how can we get the midpoint? We simply take the upper class value plus lower class value by 2. So its midpoint is simply the average of the upper class and lower class values that are present in a particular class. Simple as that. It's the average of the upper class and lower class values of a class. We get our value. Here in this case, this will be 3.5. This is called the midpoint of this particular series. So when we get this kind of data table for a group data, and we need to calculate several different things using this kind of data, what we are interested in, we need to find the lower class boundary, upper class boundary, then we need to find the class limit, as well as we need to find the midpoint. Now once we get all these informations, that will be done, because they won't tell us what is the upper class boundary, lower class boundary, class limit or class width or this midpoint. They won't tell us. What they tell us is simply they will give us this form, this table. We need to derive all these things, because these small things will be required to calculate the different things that we are going to get from this kind of data that they will supply us. Okay, so that is the basic idea. We need to derive all these values first from looking at this graph, from looking at this table, frequency table, then we'll do the job. Then we'll solve our problems. Okay, so these are the type of data that we're going to deal with, and these are the 3 types of data. Remember, first is simply non-frequency data, easiest. Second one is the frequency data, which is not having any class. It is also grouped but not having any class, so they are also simple. Slightly complicated than non-frequency type, but third one is the most complicated type, which is this one, which is having the group or the classes there. Okay, so that is it, and I hope this video is helping you to understand the basics of statistics and the data types. From the next video, we will be taking example of this kind of these 3 different types of examples of data type we have seen, and we'll be solving several problems. Thank you.